This is the C-17 Globemaster. It's 4 in the morning, February 15, 2026, at March Air Reserve Base, California. And what those airmen are rolling up its ramp under armed guard is not a bomb and not a tank. It's a live nuclear reactor, broken into 8 pieces, about to be flown across 3 states inside this airplane. And it's riding in a C-17 for one reason. This is the only aircraft on Earth that can pull it off. Not because it's the biggest, it isn't. A C-5 carries more. It's because the U.S. is trying to demonstrate a capability everyone thinks is impossible. Inside the hold, a loadmaster sets his shoulder against a steel frame module the weight of 2 loaded pickups and pushes. It glides, one man, walking 8 tons deeper into the airplane around him. Armed airmen ring the aircraft. This is what it looks like when the most dangerous sounding cargo in the country gets loaded before dawn. That 8-ton shove with one shoulder, it works because of the C-17's powered roller floor. The deck under that module isn't solid the way you're picturing. Flip a row of locks and it converts from a flat surface into a bed of motorized rollers and rail guides. Cargo that should need a forklift and a ground crew rides in on ball bearings instead. The rollers carry the load to its station, then retract into the deck, and the surface goes flat and rigid again under the hard weight. Conveyor belt 1 second, parking lot the next. The whole system runs on standardized 463L pallets, aluminum platforms with a grid of tie-down rings that lock straight into the rail guides. The base swallows 18 of them at max load. That's how 3 people handle what used to take a small army. Here's the quiet genius of it. The hard part of moving heavy cargo was never the flying. It was the loading and unloading at both ends, where a strategic airlifter can sit for hours burning daylight on a hostile ramp. The C-17 solved that on its own deck, so it can land, offload, and be gone before anyone has time to react. And once a module is parked, it doesn't move again. The Loadmaster runs chains and tie-down straps to anchor points sunk into the floor, each rated to hold thousands of pounds against takeoff, turbulence, and a hard landing. A loose load in flight is a catastrophe waiting to happen. 8 tons sliding aft on rotation would put the airplane's center of gravity somewhere it can't recover from. So nothing rides in a C-17 until it's strapped down like it's part of the structure. For a nuclear reactor, the crew runs the restraints twice and checks them twice. That crew is 3 people, a pilot, a co-pilot, and 1 loadmaster. The C-141 Starlifter this jet replaced needed 5 crew members to do less. On this plane, 1 loadmaster working the rollers and the straps arranges tens of thousands of pounds so that a 174-foot airplane safely flies level. And the room he's working in is enormous. The cargo bay runs 88 feet long, 18 feet wide, more than 12 feet tall. A small gymnasium with wings bolted on. This is an airplane that swallows an M1 Abrams tank whole, all 70 tons of it, or 3 Bradley fighting vehicles, or 3 Apache helicopters in a single load. So 8 modules of this nuclear reactor barely tested. They slide it in with room to spare. And every piece of this mission rides inside. The C-17 has nowhere to hang anything outside. No external pylons, no underwing stations. Whatever flies sealed in the belly. Never exposed, never handled in the open. Remember that when we get to why a civilian freighter that could lift this easily still couldn't be trusted with it. But the airframe is only half the reason this is happening on a ramp in California instead of a flatbed on Interstate 15. The other half is the people loading it. The unit running this is the 62nd Airlift Wing. They're the only wing in the United States Air Force certified to routinely move nuclear weapons. That one qualification is why the Department of Energy keeps handing them everything else nuclear that has to travel. They've done it before, on missions that have never made the news. The reactor went into that hold with no fuel in it, not a single uranium pellet. What rolled up the ramp is the structure, the cooling system, the control hardware, everything except the part that splits atoms. So the real danger here was never radiation in the sky over Nevada. It was doing something nobody had ever attempted, aboard an aircraft that cannot be replaced. Lose one of these and there is no reorder, no second production run, nothing. The risk was historical, not radiological. The ramps are coming up. In 4 minutes, all of this leaves the ground. That's the moment the C-17 stops being a warehouse and becomes the only thing on Earth that can do this job. 4 throttles slam forward and the airplane lunges. More than 400,000 pounds of aircraft and reactor charge down March's runway. The desert smearing past the Loadmaster's window, everyone shoved back into their seats as the speed climbs. So what just threw that much airplane down the runway? 4 Pratt & Whitney F-117 PW100 turbofans, hung 2 to a wing. Each one makes 40,440 pounds of thrust. Together, better than 160,000 pounds shoving this thing into the sky. And the core isn't some exotic military secret. It's the same power plant family that flies the Boeing 757 you've boarded commercially. The Air Force took a proven airliner engine, hardened it for the field, and bolted 4 of them onto a flying warehouse. Proven track record matters here. A power plant with millions of commercial flight hours behind it won't surprise a crew hauling a reactor across 3 states. Think about that ratio. Roughly 160,000 pounds of thrust against a 600,000-pound airplane fully loaded with cargo and fuel. That's barely 1 pound of push for every 3.5 it has to lift. And it still climbs out like it's late for something. The nose lifts. The formation climbs over the high desert and rolls onto its eastbound heading with a crispness that catches every pilot coming off older iron. It banks and settles like something half its size. A machine the length of a blue whale has no business feeling nimble. This one does. So what lets a 174-foot airliner move like that? The C-17 was the first large military transport built fly-by-wire. No cables, no pulleys, no hydraulic muscle running mechanically from the stick to the surfaces. The pilot moves the controls, a computer reads the request, and electric signals tell the surfaces what to do. 4 redundant layers run the system, with a mechanical backup underneath in case every computer quits at once. Lose the primary, you're fine. Lose the backups, you're still flying. Fly it empty, and the crew can pitch it into a climb that looks more like an airshow maneuver than a cargo run. All that responsiveness hides a math problem, though. 8 tons of reactor in the wrong spot and the airplane fights its own pilot. Too far forward, nose heavy. Too far aft, and the tail sinks. That's why the Loadmaster back on the ramp wasn't just stacking boxes. He was solving the equation that decides whether the jet flies level. Takeoff is the easy part. The flying between 2 runways is what this airplane was built for. And the reason a bigger, older airlifter parked right next door couldn't be trusted with this morning's cargo. This is the airplane that shows up when the situation is impossible. Combat zones, earthquake-cracked runways, the largest evacuations in American history. The reactor is a new kind of cargo, but the job underneath it is the one the C-17 has owned for 30 years. Deliver the undeliverable into places that shouldn't be reachable and make it look routine. Level at altitude. The 3 jets settle into the run east toward Utah, which is the moment to answer the question sitting under this whole operation. Why this airplane? Why not something bigger? Here's the impossible job the C-17 was built to do. For decades, moving military cargo by air forced a brutal choice between 2 completely different aircraft. The C-5 Galaxy hauled the heavy stuff across oceans, tanks, helicopters, mountains of gear. But it needed 6,000 feet of pristine pavement to set that weight down, which meant it only could ever land at a real airport. The C-130 Hercules went the other way. It could thump onto a short dirt strip a few hundred yards from the fighting. But its cargo box topped out near 42,000 pounds, enough for troops and supplies, nowhere near enough for a main battle tank. So every airlift planner faced the same wall: reach or access. Almost never both. The C-17 refused the trade. It hauls 170,900 pounds, the weight of 2 loaded 18-wheelers, across a 2,400-mile leg at close to the speed of an airliner. That's a heavy lifter's resume. Then it turns around and does the tactical job too, airdropping 102 paratroopers or flinging 60,000 pounds of cargo out the back over a drop zone. On paper, asking one airframe for all of that is like demanding a pickup truck that also wins Formula One. Those different requirements fight each other. So why didn't the Pentagon just grab a C-5? Because the answer was never tonnage. The C-5 carries more. A commercial freighter, like the 747AF or the giant Antonov AN-124, they could lift these modules too. Raw capacity was never the problem. The problem is everything that has to be true at once. You need the muscle to carry it. You need to operate into a short, locked-down, austere field where the cargo never touches public ground. And the whole way there, that cargo has to stay inside an unbroken military chain of custody, flown by the one wing the country trusts with nuclear material. Only one aircraft on Earth checks all three of those boxes at the same time. The C-5 has the payload, but fails the field access test. The freighters have the payload, but fail the custody test. Because the moment a reactor rides on a civilian registry, it's a different kind of problem entirely. The C-17 passes all three. That's why it even exists, and why it was the only real choice this morning. Which brings us to the thing the C-5 and every other freighter on Earth physically cannot do. Hill Air Force Base is coming up, and the C-17 is about to put itself down in a way that shouldn't be possible for an airplane this big. The C-17 noses toward Hill on an approach that looks wrong, too steep, too slow, far slower than anything this size should fly without falling out of the sky. And yet it hangs there, stable, descending under perfect control, and settles onto the runway like it weighs nothing. That slow motion approach you just watched, that's powered lift, the cleverest trick the C-17 owns. On most airplanes, fly too slow and the wing quits making lift. Then you stall and fall. The C-17 cheats, and it cheats by aiming its own four engines at the problem. The flaps drop straight into the exhaust of all four engines. The blast slams over and through them, and now the wing isn't living off the air it's flying through. It's getting a hurricane of jet exhaust forced across it, making nearly double the lift a normal transport aircraft could manage at the same speed. Engineers call it externally blown flaps. The harder the engines push, the more lift that surface generates. So the C-17 can drag itself down to an approach speed that would drop any other airplane its size right out of the sky. Picture a leaf blower aimed at a sheet of plywood, lifting it off the ground. Now scale that up to 4 jet engines and a 170-foot wing. That's the exact opposite of how you'd expect a landing to work. Add power, get more lift, fly slower. And it's exactly why this fully loaded airliner can touch down at a crawl. And the crawl is important. The jet rolls out and stops short, brutally short. A 174-foot aircraft pulling up in 3,000 feet of runway, less than half of what an airliner needs. And it'll do the same on dirt that's never seen pavement. Reach plus access, the thing the C-5 and the C-130 could each only manage half of. All that weight comes down on a stalk of gear with 12 main wheels, split into 2 pods of 6 and spread wide so the load presses down through a big footprint instead of a narrow one. That's what lets it set down on dirt or sand that would punch a lighter, narrower airplane straight through the surface. The gear rides low on purpose too, holding the cargo floor near truck bed height so a forklift drives straight up to the ramp without a loading dock. Even the way the airplane sits on its wheels is built to get heavy things into places that have no business hosting an aircraft this size. That short field skill is more than a party trick today. It means the destination doesn't have to be a sprawling airport with public pavement and crowds watching the ramp. It can be a small, locked-down military field where the cargo never leaves secure hands. For normal freight, that flexibility is a convenience. For a reactor under armed guard, it's the difference between a mission you can run and one you can't. Then the C-17 does something absurd. It starts rolling backward. A 174-foot airplane reversing under its own power, then pivoting a tight 180 in a space barely longer than its own body. Look at the engines now. They're running backward. Thrust reversers. They direct the exhaust up and forward instead of straight back. And on pavement, that's routine braking that shortens the rollout. But aim that blast at a dirt strip, and it throws up a wall of grit so thick the airplane vanishes into its own dust. A total brownout. That's exactly why the exhaust points up and forward, to keep the 4 engines from eating the debris they're throwing across the strip. The same system walks the jet backward off a parking spot and spins it through a full turn in 80 feet. No tug required. Fully loaded, it'll even back itself up a slight grade under its own power. Try that in a C5. You're calling for a tug and a tow crew and waiting an hour. Ramp down. The roller floor runs backward and the modules roll into the Utah daylight. The airplane's job is finished. The cargo's isn't. A convoy takes the modules the last leg, southeast out of Hill toward the Utah San Rafael Energy Lab in Orangeville. There, over the days that follow, the crew bolts all 8 back into one machine, the Ward 250, built by Valar Atomics, a nuclear startup barely 3 years old that calls this the start of a second Manhattan project. This is what the whole morning was for. At the lab, a technician holds up a single fuel pebble between 2 fingers. Between his fingers is the one thing that lets this reactor ride in an airplane at all. That's triso fuel. Triso, tristructural isotropic, is a mouthful for a simple idea. Inside that little sphere sit uranium kernels the size of poppy seeds, each one sealed in its own layers of carbon and ceramic. Each grain is its own containment vessel. Crack the shell, crush it, overheat it. The radioactive material stays trapped inside the coating around each individual kernel. The uranium runs high-assay low-enriched between 5 and 20%, hotter than what a commercial power plant burns, nowhere near weapons grade. Pack enough coated kernels together, and you get something that locks its byproducts inside even when everything around it fails. This is what wasn't on the flight. The modules flew empty, structure only, so that none of it had to be in the air over 3 states. Set the fuel aside and study the core the crew is bolting together. No cooling tower, no giant water loop, none of the plumbing a power plant needs. Just a sealed gas circuit and a core built around blocks of graphite. That's the tell. The Ward 250 is a high-performance gas-cooled reactor. Helium for coolant, graphite to slow the reaction, running hot at 750 degrees Celsius. Helium is the part that matters. It's chemically inert, and it stays a gas no matter how hot the core runs, so it can't react with anything, and it can't change its state on you. There's no water to flash into steam, no pressurized loop waiting to rupture, and nothing that can build into a hydrogen explosion, the failure mode that haunts every water-cooled reactor. Coolant boils off, fuel overheats, and the whole thing races toward a meltdown simply isn't on the menu here. Take the water out of the equation, and you take the runaway out with it. And here's the feature that makes engineers light up. Cut off all the coolant, the worst thing you can do to most reactors, and the Ward 250 doesn't melt down. At these temperatures, the leftover heat radiates out through the structure faster than it builds up inside, so the core levels off at a temperature the materials can take and simply sits there. It cools itself by doing nothing. Nobody runs a pump. Nobody flips a switch at 3 in the morning. The safety is physics, baked into the laws the thing runs on, and physics doesn't take a coffee break. Now the honest scale of it. The unit in Orangeville is about a 100 kilowatt experimental test reactor, a proof of concept, not yet a power plant, built to validate the design before anyone scales it up. But the Ward 250 design is meant to climb toward 5 megawatts of electricity, enough for 5,000 homes, out of a package small enough to ride in a cargo bay and get bolted together in a few days. And that scaling target is exactly why a reactor ended up on an airplane. Most military bases hang off the civilian grid, the same aging wires that feed the town next door. And that grid is fragile. A cyber attack, a storm, a saboteur with a plan. Any of them can cut the electricity outside the fence and leave a base running on diesel generators that need a constant fuel convoy to keep them alive. And fuel convoys get attacked, which is how an electrical problem turns into a casualty problem in a war zone. A reactor that you can fly into an austere field and switch on breaks that whole chain. It's a base that never goes dark, no matter what happens to the wires it used to depend on. This morning wasn't a delivery. It was a rehearsal for a future where power itself is something you airlift in and plug into the fight. And that future is coming fast. The whole effort runs under a federal pilot program built to get small reactors tested in a hurry, driven by a surge in demand the old grid was never sized to carry. The military wants bases that can't be switched off from outside. The country wants power that scales. Operation Windlord proved the delivery of half of that promise actually works. The Ward 250 sits reassembled in Utah now, waiting on the fuel it didn't carry, due to go critical by the 4th of July 2026. And somewhere west of it, 3 C-17s are already turning for home. The only airplanes that can put a payload like this down on dirt, back themselves out of it, and be gone before anyone reacts. The reactor is the future, but for now, it only goes where the C-17 can take it, and there will never be another C-17 built. If you enjoyed this video, then you should see how the world's biggest military cargo plane can literally transport tanks across the globe. Bye for now.